CSS. So if you ask questions in the chat, they'll be able to help you out. So before we get started, we might just introduce people in the committee just so that you guys can know who to talk to today if you're having troubles. And when we go through the breakout rooms, they'll be helping you run through some questions because we want to try and keep this session as interactive as possible. So we might start with, we've got Jeremy. You might be able to see him because you waved, Jeremy. So he's actually the president at the moment. And then we've also got Varun and Jessica. Yes, it's being recorded. And Josh and Yushu and Shredder and myself. And we're all part of the committee for this semester. So if you haven't signed up already, please do and follow all of our social media pages. We're also currently recruiting. So if you want to join, you get really inspired by this workshop and you want to join, make sure you apply. And we hope to see more of our events and we hope you really enjoy our workshop today. So Josh, if you could start with our lesson, please. And I'll be sending some links through the chat, everyone. So make sure you keep an eye on them.
All right. Hello. So yeah, I'm Josh and I'll be taking you guys through the workshop today. We have the links in the drive here and that'll contain the workshop content. So if you could just go to that link that I've just posted there and you can download both the R&D and the HTML files in there. So to set up that R&D, I'll share my screen quickly and you go to the link here and just download this. And so has anyone not installed RStudio? So we sent out a little like a message in the email, instructions how to do that. Has anyone not managed to get it up and running? Or have there been any issues with that? No, all good. All right. So if it's all good, we'll go on to the workshop. And so in terms of using R, this is RStudio, and this is the layout of RStudio. And so in here, you'll be able to see all the code that's been written. So this is what's called an R Markdown document. And that means we can put code and text together, which is really helpful for sort of data analysis. So we have the code here with the 3 backticks and then the R setup.
Josh,
oh,
we're not seeing your R.
Sorry, is that all right?
Yep.
Sorry about that. All right, so here's the layout of RStudio. So in here we have all of the text. So this is all the code. This is the format. And so in here we have chunks of code, which is the darker sections. And here's the code. And then here is just text. So we can do data analysis on this and we can write text in here and we can write code in here. And so if you haven't installed the tidyverse, you open this document and then highlight these 2 lines and press Alt-Enter or Command-Enter on Mac. And that'll install the package tidyverse and load the library. And so mine are already loaded, but if yours aren't loaded, then you should do that now, just so that it takes a couple of minutes to install. And otherwise we'll get to the point where we start using these packages and it'll take people a while. So this is just a set of extra stuff that's really helpful for data analysis. And so it seems like a lot of people have done at least a little bit of programming before. If you haven't, don't worry, there's not like, we're not going to go like that in depth into like sort of computer science programming and stuff like that. This is more just learning R for data analysis. So here we're assigning a new variable, and the way that you create a new variable might be a little bit different from Python or any other language, in that we use this operator for the equals. So it means take hi everyone and put it in new var. So let me just clear that. So in here, you can see all of the variables you have saved. So if you want to see the variables we have nothing at the moment. And now if we run this, highlighting it and pressing Control Enter, we can see that we have a value called new var, which is our new variable, and in the field it's hi everyone. And so now sometimes we want to print things out. So here we'll print out the new var to the console. And to do that, we press Alt Enter on new var, and we'll see that it'll print out over here. So we can keep stuff together. So we can put stuff together. So sometimes we want a bunch of variables and we want to keep them in one place. And so this is called a vector. And this will keep 5 different variables together, and it'll bind them to a variable called numbers. So if we Control Enter there, we can see that we run this function on numbers, and the name numbers, we've saved this variable up here. And if we can call functions on these, so this is the square root function. So if I call the square root function on my numbers, then numbers. Sorry, if I call this on sum on the numbers, then it will sum all the numbers together. All right, my top left window is empty. Okay, so you have to open this in here. So you just do you download the file you download the file, and then you click File, Open File, and you locate where you downloaded it. And then you'll open it like that, and then click Open. So if you haven't managed to do that, what's the difference between Control Enter and Alt Enter for running code? I think one runs the entire chunk and the other one runs just the line. The download link is there. So there's the download link. So here we are, and we can call this function here, numSum, and this will sum up our numbers and save it to a variable called numSum. And so you see this sums it up, and it's 21 there. We can take the square root of that, and that'll print to our console. So that's fairly basic, sort of just some elementary stuff. So if you haven't been able to install it, you can use RStudio Cloud, but it seems like everyone's managed to install it. It's quite easy to use this. So if you haven't, just go to that link and follow the instructions. If anyone wants me to go through, type in the chat now, but otherwise I'll just move on. So the Magritte pipe is
Maybe could you just show quickly, just in case people aren't comfortable with saying that they haven't got it?
Yeah, sure. So we go to here and we go to this link, and we'll go here, paste that in. Now, if we want to log in, and you can log in with your Monash email. So log in with Google, choose your account. And then we get into here. You have no projects, so you've got to click New Project. And then this will take a little while. And so you want to download this onto your computer while this loads. And then you can use, for my job, I use RStudio in master, but you can definitely use VS Code. It probably depends on what organization you're from. So then here, and you just click Upload, and you'll have to upload the files you just downloaded on RStudio Cloud. And then once you've uploaded those files, you can just click on them in here. So I just choose File, and I pick my file. So that should cover it for RStudio Cloud. If you get stuck, let go. Let me know. But otherwise, we'll move on just using the desktop version. They're really similar. I mean, Yeah, you'd use RStudio Cloud because they let you buy like GPU power, but we're not using enough data for that at the moment. All right, so this is the Magritta pipe character that we were talking about before. Okay, so you can ignore this. You can ignore this first line of code and start running it from here. This just tells it what to look like when you. Yeah, that won't affect the functionality. So we have our Magritta pipe here, and we insert it by pressing Control-Shift-M. And what it does is it takes this and puts it into this function and evaluates it, and then puts it into this function. So we take numbers and we sum them together and then take the square root. So here we run this and we have our numbers from before and we sum them and then we take the square root. And then here we can take our numbers, square them, sum them, and take the square root. So this dot character will represent whatever is before. And so this lets us do this quite elegantly, like combine multiple functions. And so the pipe is this thing is the pipe. So you take this and you pipe it into this. And so you go the numbers and then square root, and then square them, and then sum them, and then square root them. So we often use this for entire data sets. So it might seem like silly to just do it for like one little thing where you can just take this and then do the sum and then calculate it for that. But if you're doing it for big data sets, it makes it a lot easier to read and just a lot easier to figure that out. And so today's session will focus on manipulating data in R. So R is obviously used mostly for data science. And so that's what we're going today, just for the basics of reading and manipulating. So when we deal with data in R, we typically want to keep it in a tidy data format. And so there are 3 rules. Each variable forms a column, each observation forms a row, and each observational unit forms a table. So we don't want like repeating units in the columns. So stuff like, we want each observation to be in a row. So we don't want to mix things together, and we want each observation to have its own row. Here we have, so when we store our data, we'll store it in a data type called a data frame. It's similar to like an Excel spreadsheet in a way, but there's a lot of like functions that we can call on these data frames that allow us to filter it and do certain things like that. So the way that we read it is we write read the housing data, and we're going to save it, and we're going to call this function read CSV. So we're going to read it from online because it's easier than having everyone download the data, but you can do this with any local CSV file. And so we run this line and we'll read the CSV file and we run that. And so we see in house data, we've saved this. So here we have a new data. We have house data, and we can see we have 13,000 houses and 21 variables. So we're taking the house data and we're reading it, and then we're saving that in house data. So we've saved this over here. So to allow us to view the data frame that we've just read, so we've obviously read all this data, but we want to see, what the data is. We know it's got this many observations and this many variables, but we want to have a look at what the actual data is. So we can use the head to print the first few lines onto the console. So if we run that here, we'll just get this here. And we can see that it's the sales of every house. So we have like the suburb, the address, the rooms, the type, the method, the distance, the postcode, bedrooms, bathrooms, location, year built, building area. You can also use the view function to view the data in RStudio. So if we run this, you'll see it pops up a new tab here. And in this new tab, it looks essentially, it'll look like an Excel spreadsheet, I guess, or a database table. And so this will let you sort of see every individual row and scroll through the data like that. If we want to extract a single column, so sometimes we want to just have a single column on this for certain purposes. So we get all the addresses, or so you can imagine if we have email addresses or something, we'd want a list of like all of the email addresses, or all of these addresses to, I don't know, look them up for some reason. So, or all of, say, in this case, the real estate agents, we can use this $sign. So this says take the column from house data and take the column that is called sellergee, which in this case is the real estate agent that sold the house. So we can see here, these are our first few real estate agents. So head is again the first few rows. And so this will give us big and big and big and big, and we're the first few real estate agents that sold in this data set. And similarly, we can use unique to see all of the unique real estate agents. So if we run this code here, it's a lot of real estate agents, but you can see all of the real estate agents that have made sales recently. So here, Bridget will take over and she'll explain like some of the simple data wrangling processes. So how we can sort of get this data and figure out questions like how many houses did a certain real estate agent sell, or how expensive are houses per bedroom, or what are the most expensive suburbs. So Bridget will take you through this section. I think you're on mute, Bridget.
Yeah, I was just trying to find that button. Sorry. Thanks,
Okay.
guys. Also, really awesome, all the questions in the chat. So if you have any questions at all, please just drop them down. It's hard for the speaker to answer them all, but there will be other committee members in the chat answering them. So don't feel embarrassed. Any question is a good question. We just want you to be able to follow along as well as possible, so that when we get to the breakout sessions and we can answer questions on our own with the help of a committee member, you'll really be sort of ready to answer them, and you won't have too many questions, and you'll be able to get into it and really be able to show off what you've learned tonight. So awesome. So now we're going to go into these functions, and they're all sort of English verbs, and they are part of the tidyverse package, and they're used mainly for data manipulation and wrangling, which I'm sure you guys have probably heard of. So this is when we're trying to get our data from the original format into a more machine readable format. So something easier for our computer to process. So in tomorrow's workshop, we'll be working on graphing. So if you haven't signed up, make sure you do, because we're going to make some really awesome graphs. But before that, we really need to get these sort of basics down packed. So the first thing we have is select. So select is when you want to pick certain columns from your data frame. So as we can see, this data frame has 21 columns and 13,000 rows. So maybe we don't want all of these columns. So we can see down, you know, maybe we think postcode, distance, bedroom, they're not columns we're sort of interested in, or maybe we only want a certain select columns. So here we can see that we only think that we want suburb, address, price, and bedrooms. And this is also easier for you when you're manipulating, but it's also better for really large data sets. So in some of the units, if you're studying MDS, Master of Data Science, or other FIT, or in research, or whatever you're planning to use R for, if you have really, really large data sets, maybe millions of rows, the more columns you have, the more data you have, the slower it will run. So it's good to be able to pick the ones that you only really need to use. So here we've decided to grab just these, and we're taking them from the house data set that we've been using. So we're using that pipe to make it go into, so we're telling it that we just want the house data set, and that we want to select. So this is showing us that we're using that. And we're going to save it into a new variable called house prices. Okay, I can see that there's some good questions in the chat. Hopefully someone in the committee can take that for you. While we go through the workshop, Josh, are you able to answer?
Yeah, so sorry.
Do you want to just answer in the chat, please? Okay, so now we can see that we've grabbed the house prices. So we've got these 4. So we've transformed our large data set into just 4 columns. that's the select. So if you want to do that, you can use select. Other ones we have filter and arrange. So there are two different functions that we can use. So as you can see, this paragraph filter is when it's a really useful one that we can use, where we want to filter on a specific sort of criteria. So say here, we only want to have data from this data set, that house properties that have been sold that only have more than 3 bedrooms. So we only want really large ones with more than 3 bedrooms. So then we can filter it. So the syntax for filter is we have the data set and then we have the criteria we want. So we have house prices data set, which is the one we've made just above. And then we're selecting ones with only more than 3 bedrooms. So we're going to call that 4-bed because it has 4 or more beds. How do you select variables not in standard? So I'm not really sure what your question means. Are you able to maybe send that again?
Hi. Well, like for example, if you define a vector with the variables, do you put the vector as input of the select directly, or how do you put it? Because for example, in data table is not as making put it exactly like the vector inside the select.
Okay.
So if we want to use select, so this is the name of the column. So we have select here, and then here is each column. And so what we want to do is we want to select only a certain subset of the columns. And so we pipe this in here. And so the way that the pipe works is this will be the same as, say, select from house data, suburb, and then all of the other variables. So we select from the first argument, and then the rest of the arguments are the columns that we want. Does that help?
No, exactly. It's like defining apart the vector with the variable names, and that vector put it in the select as argument.
Oh, I don't know if that works. You might have to try yourself. I think I would, if you want to create a new column, then you'd bind it with like, you go house prices. So if you have a new column, say of like, I don't know, the seller's email address or something like that, you can go something like house data and then email addresses. And then bind it like that. And then this would be your vector. And then in here, you would add email addresses. If there is some way where you can add vectors in the select, then let me know. But that's how I would do it, I guess.
All right, Josh, I might just have to scroll up quickly for a second.
Oh yeah.
Some people have found they're having trouble with tidyverse suddenly. So guys, one thing to notice about R that's a little bit different to other programming languages is first you have to install it. So the very first time you ever use this package, you have to install it, but only once, unless you use a different computer. But even though today we've installed it for the first time, you still have to load it. So you have to load it, library tidyverse. So after you've installed it for the first time, you can comment it out using the hash. So just run it once, and then once you run it, you need to download it. So if you find, for example, so every time you reuse R, you have to reload the libraries every time you open the file again, but you don't need to install it more than once. So if you find that the file that Josh has uploaded on his GitHub isn't running for you, that means you haven't installed tidyverse properly yet, because read_CSV is a tidyverse package. It's a tidyverse function. Yeah, that's right. So you have to import it every single time you open it. but you have to install it the very first time you ever use it. So for all the people that are having trouble with that, please go back and try those steps. If you're still having trouble, please send it in the chat, but please just be patient while somebody tries to help you out, because if you send too many messages, it can be hard for them to respond. So just try that, and then if it's still not working, just let us know. Okay, so going back, so the Magita pipe, read, none of that will work unless you properly install Tidyverse. So if the code's not running, it means that Tidyverse isn't installed properly yet. But if you're still having trouble installing it, then just let us know in the chat, please. So yeah, so select is just for selecting different columns in the data frame. It's not sort of like selecting certain variables. That's actually more like filter. So filter is selecting rows by a certain criteria, and select is for selecting columns in the data frame. No, we generally don't have to restart R, but you could try if you think that might be the problem, but it should be.
You can
Yeah,
also,
it may still be loading. It's quite a large package, so it may still be loading. So if it's come up at the bottom in your console and said that's finished loading, it's finished loading, but it may still be loading. So you might just have to give it a little bit more time. But we will be able to help you in the breakout rooms later. So if you're still having trouble and we can't help you in the large room, just know that once we get to the breakout room, we'll have enough time to help you debug and be able to go through the questions. Okay. So for filter, that's when we're filtering by rows. You need to think of it as rows for a certain criteria. So for example, we have here, we're using the house prices dataset. So we've selected the certain columns we want, and then we're doing it by bedrooms more than 3. So we've named our variable 4-bed so that we know later that that's what it's talking about. So it's good to always give your variables names that are similar to what they've been created for, so that you don't get confused. So once you've filtered, you can also additionally arrange the data if you'd like. So for example, we've made this 4-bed variable, and we've filtered them by bedrooms that have more than 3 beds. Properties have more than 3 bedrooms. And we want to arrange it in descending order of price. So we want the most expensive property first, and then going down. And then here we put the variable name to print it out. So you can see here that we're using the pipe. So if we use the pipe, it's telling R that we want to use this data set to do this function. So there are multiple ways in R to do things, just like there are in other languages. So usually we use the pipe to stop us from having to rewrite the code, same code again and again and again. So if we wanted to string together functions, we can use the pipe to put, for example, the data set out the front here, but we can also call the data within the function. So it's just a handy tip to help us sort of string them together in a shorter lines of code. But you just think of it as what's on this side is going into that side. So this data set here, 4-bed, is going into this arrange function.
Yeah, so it puts it as the first argument, right? So yeah, you can write that. Yeah, so this will take 4-bed and put it into the first argument of a range. So you can imagine if we have something quite long like this, where we do multiple different operations, rewriting it without the pipe, we can either save the variable each time. In that case, we get a whole bunch of different variables, and the naming can get quite confusing. Or we write it as like nested functions. So we'd write something like group by, and then like it'd be a function within a function within a function within a function. And so the pipe kind of resolves that issue and allows it to be quite readable, where we can say, oh, we take the house data and then we group it by this, and then we do this, and then we do this. So the pipe doesn't actually make anything like quicker or anything like that. It just makes it a lot more readable. And so that's sort of the point where you can read it almost like you can read like an English sentence. and that'll make your code like a lot more maintainable, and it makes it a lot easier to understand what you did in the past and to send it to peers and stuff like that.
Yeah, awesome. So thinking about filters, we're filtering sort of out rows. So we're getting rid of rows if they meet a certain condition. But select can get a bit confusing, but select is basically we're selecting the columns we would like from the data frame. So for example, like our original data frame has 21 columns, but we only want 4 of them. So we select the ones we want. Filter is we've got 13,000 rows, but we only want the rows here, the 3,000 rows that are properties with more than 3 bedrooms. Hopefully that can help you guys with some of the questions we have. So next we have a really important part of Tidyverse, in my opinion, that can take a while. It took me a while to understand because they sort of work together, but they're very important for especially when you're visualizing or sort of doing things like that with the data. So we have group by and summarize. In my opinion, you can kind of think of them as functions that often go hand in hand. So they work really well together. So you can see in our example here, we've used the mean, but you can use within summarize many different functions. Ones that are often used are mean, like we will use, count, min, max. So I'm guessing that you can see from their names, they're quite descriptive. So mean takes the mean, count takes the count, min returns the minimum value, and max returns the maximum value. So these mean, count, minimum, and maximum can also be used just within normally if you want to take the minimum or maximum values of things. But we can use them really well in group by and summarize to make some really awesome sort of changes to our code. So as you can see here, we've got our new variable suburb mean, and we're going to create what we're going to have in that suburb mean now. So we're going to use the house data, which is the original data set. So we're going back to that original data set, and we're using the pipe to show that that's the data we're going to use for these extra functions below. So we're going to group the data by suburb. So for each suburb, there might be, 20 properties listed. So we have all of these, we have all of these properties here. So for example, you can see even just for Abbotsford, which is a suburb of Melbourne, there's, more around 40 properties. So what we're telling R to do is to group all of those properties from Abbotsford together. So it's going to do that for each suburb. They're going to put them all together and then summarize. It's going to take the mean. So it's going to take the mean of all of those properties by the group, which we've declared as suburb. So for each suburb group, it will be like Abbotsford or Airport West or Clayton or Caulfield or any sort of suburb that we know in Melbourne. It's going to group them all in the data set and it's going to take the mean of them. So you can see how that's quite powerful. So you can easily see what the mean values of properties are. So a reason we might want to use that is if we want to decide what are the most expensive suburbs to buy houses in, or what are the least expensive suburbs to buy houses in. So you can see here now, this new data frame, it's got 2 columns, suburb and mean. Can I increase the font size? That's a good question.
Yeah, I'll do it.
By definition, in my opinion, R is quite zoomed out, but we can zoom it in for you.
All right,
I think in view, Josh, you can zoom in.
It's a little bit better.
You can use group by for different purposes. Like there are some other sort of niche purposes, but generally I would say I only really use it with this summarize function, because you're taking a group and then you're summarizing whatever it is from the group. Maybe you're summarizing the minimum, maximum, mean, I don't know, standard deviation, whatever you want to find from that group. So you could group through different things, doesn't have to be suburb. We could have grouped from bedroom count. So we could group it by all the properties that have 1, 2, 3, 4, 5, 6 bedrooms. So we could group by any of these and we could find anything. We could, instead of finding the, yeah, so it's quite similar R. A lot of these tidyverse functions are very similar to SQL. And I think it's good if you can find sort of associations. So here we've decided to find the mean, but we could find the max. So it could return to us the max property price for each suburb, or the count, how many there are for each suburb, or the max, or any of those. Hopefully that makes sense.
So if we just summarize, I think if we just straight summarize house data, and we take house data and summarize it by the mean is the mean price, it'll calculate the mean price for every single house. But the group by will split it into suburbs, I think, yeah, is what Bridget said, yeah.
So if you use summarize, it will just do it for each row, which won't really make sense because there's the summary of each row is the row itself. So it's summarizing that group in a sense, but I'm sure there are some niche users of it outside of group by. There is always sort of exceptions to the rule. Maybe there'll be some good homework for some of you to sort of to look, but generally they are sort of seen together, and that's one of the more powerful and common usages. And then, oh yes, so now we're just showing that we can arrange it. Yeah, so it is being recorded and will be shared with you guys. Don't worry about that. So remember before we looked at arrange. So that's just a way of ordering your data. And it can be really good if you want to take, say, the top 10 or the bottom 10 or the middle 10 or whatever you want. You should arrange it first. So it's sort of like a sorting. So here it's very similar to the one above. It's just that this time we've put an extra pipe because we want to arrange it into descending order. So we want the most expensive suburbs first. So you can see here in this data set, it's returned that these suburbs are the most expensive in Melbourne. But if you are quite familiar with Melbourne or any sort of data that you're looking at, it's always good to sort of take any good data scientists or analysts will always take data with a grain of salt. So if you look at something and you think that it seems kind of wrong, I'm not saying that this data specifically can be, but any sort of time you think that data might be a bit funny, that means that there could potentially be outliers or other things that we need to address. And if you're really interested in that, we will be doing that tomorrow as well. So make sure that you come to that. But for now, we are on our most important basics. So I think this is our next one, mutate. So mutate is also another helpful one that I find can be a little bit confusing sometimes. So mutate we use to make a new column in our existing data frame. So for example, we have this house data frame that we've had from the beginning. It's our original data frame from our CSV file. So what we're going to do is we're going to add a new column into our data frame. So we want to add a new column and we're going to call it price per room. So whatever you put before the equal sign is the name of this new column. So if you don't put an equal sign there, it will call it price / bedroom. It will call it this really long name here. So just make sure that if you have a data frame that shows that, you need an equal sign and you can put your own variable name there. So what we're going to do, we're going to pipe this data set in and we're going to mutate. So that's telling R that we're going to make a new column. We're going to call it price per room. And what it is it's the price column divided by the bedroom. So the value, how many bedrooms it is, plus half of the amount of bathrooms it is. So that's how we're going to calculate what's the average price per room. So it's going to sort of take the bias out of really large houses and really small houses and see what sort of is the average price for a room in that sort of property. So you can see here, it's going to be at the end because it's a new column that we've put in. So you can see here that for this property, the price of the room per each room is this, and so on. And it is still, sorry, I got distracted. So that's our new column. So you can see here, it's calculated the price per room for each of the properties. So you could use Mutate to make any sort of column you want that you could think of. You could take the year built and you could take that away from this year's 2021, and you could make a new column that gives you the age of the house. Realistically, you could, there's many options, but you have to use the Mutate function if you want to add a new column to an existing data frame. So putting together all those things that we just went over then, as you can see, we're using our pipes so that we can just keep adding in extra functions to our original set of string of functions. So as Josh said, this saves time from having to make variable after variable after variable, and it's nice and readable for both the computer and yourself and anyone else who sees your code. So as we just went over, we've got our original data set, then we're mutating in the new column, then we're grouping it by council area this time, so not suburb, we've decided to do council area, then we're summarizing it. So we're summarizing it by the median for the price per room, and then how many rooms for each of those council areas. And then we're arranging it from most expensive to least expensive. So as you can see here, there's one that's unavailable. So, and then it goes down. So it's telling you sort of the suburbs, which are the most expensive. And then I guess you can look at the count, and that gives you sort of how reliable the data is. So, you know, if it has a lot of count, then you can see that the data is quite reliable because a lot of these are there. So we're almost finished our workshop section. So Josh is going to start leading us through joins, which are very similar to SQL, as some of you have been sort of saying. I'm going to start sorting people into breakout rooms, but please don't go into them until we say that it's time. So if you get a notification about it, just ignore it for now, and we'll be going into them later. I'm just letting you know, just so you don't get shocked. But Josh, if you could lead us through joins, please.
All right. Okay, cool. So this is some stuff with joining data. So I think we have time. What's the time? We're good for time, right?
Yeah, we have time.
Okay, cool. All right. So this is for joining data together. So sometimes we have like separate data sets that we might want to join onto this data. So for example, here we have the demographics of each postcode. And so this is being wrangled from the Australian Census website. So we can see if we run this and we see the postcode demographics, we can show that here, and we see that this is the postcode, this is the age group and the number of people in that age group. So Melbourne between this age has 11,000 people, and this is this postcode for central Melbourne. And so we can summarize, we can use that like that. And so this is some data that we've read in from the internet again. And here we have the ages over 45. So this is just going to be a little recap from some of the stuff we've learned before. It does use some new stuff. So don't really worry if there's some stuff in here that you don't recognize from before. But here we have the ages over 45. So these are all the age groups over 45 in the data set. And we're going to use this, and we're going to group by postcode, and we're going to summarize, and it's going to have the sum of the number of people that have their age group in ages over 45. And then we're going to have the total number of people, which is just the sum of the number of people. Then the percent of the people over 45 is just 100 times the number of people over the total. And then our population is our total. And then we just want to select total and over 45. Oh, sorry, want to remove. So select minus means we're going to remove those two columns. So you see here, we can run this, and run that first, and then we run that. And now we see this. We see each postcode, and then this is our % over 45 and our population for each postcode. So now, for example, if we wanted to, if we want to see what, if there's some relationship between like how many people over 45. So often people say that like the baby boomers buy all the nice houses. And so we'll sort of investigate that, and the baby boomers are the people who are born between 1945 and 1960 or 1970 or something. And so that'll be the people over 45. And so we're going to join this. So we're going to join the postcode onto our data set of houses. So we're going to have each house, and then for the suburb, we're going to have the percentage of people in that suburb over 45. And so we're going to aggregate the postcode data here to the data to the postcode level. So it's the same as the previous data from before, just with we're grouping by postcode, not by suburb. And so here we have the postcode, the price per room, and the number of houses sold per room. And so here, what we want to do is join this data together. So you see we have some stuff here, our postcode, the percentage over 45, and the population. And here we have the postcode, price per room, and the count. So we want to say, okay, match up each column on postcode and sort of join it together. So each row is a postcode, and we have 5 columns now. And so we do that by using the left join. So the left join takes everyone on the left-hand side and only the ones that match on the right-hand side. So it'll take every postcode in our house sales and only the postcodes that match from this postcode over 45 data, and it'll join them together. So here we have the postcode here, the price per room, the number of houses sold, the percentage of people over 45, and the population. And so if we want to investigate that here, so now we've joined these two data sets and we can see, well, is there a relationship between the price per room and the percentage of people over 45? And so we'll select this, and we're just going to plot this. So we'll go over all of this next time. So you won't need to understand this yet. But if we run this code here, we'll see that we can generate this graph here. And this will have each postcode, the number of houses sold in that postcode, percentage of people over 45, and the price per room. And we can see by fitting a line that there is kind of a weak relationship. And maybe if you have a better background in statistics, you'll be able to tell us how significant that is. And so, yeah, that's it for the workshop. If you have any questions that I missed, you can retype them. Let's see, I'll go through. Otherwise, we'll go into breakout rooms and have a go at these problems. They'll be super useful for your work, your university. A lot of stuff like this will come back up. I think someone asked, why don't we just use data table? You absolutely can use data table if you know how to use it. They're competing things, the dplyr library and data table. I mean, you can read online the pros and cons. I think there's even an article where the creators argue about which one is better. So count n will create a new column. So what does the n do? N is the number of rows. So in this case, n will be the number of rows, and each row is the property sold. So this will say, well, 103 properties were sold in postcode. So the n function just counts the number of rows. And then why have we used equal for ages over 45? Oh yeah, so equal works. I don't know the exact thing. I think this is actually just a typo, but equal will assign variables. I think it can cause issues in some situations. So there's something complicated about like scoping and stuff, but it will normally work.
Yeah, and also equals is generally used to assign sort of within functions. So best practice for R is to assign variable names with the arrow. It does work, but like Josh said, certain packages as well have different conflicts. So one of the great things, yeah, that's right. So one of the great things about R is that it's completely sort of open source and people make packages all the time. One of the sort of difficulties with R sometimes is a lot of packages have similar names and they have sort of competing ways of being ran and functions that way. So sometimes things can run, but they aren't necessarily best practice because they can sort of have conflicts. Just before we go into the breakout rooms, does anyone have any real pressing questions? Otherwise, we might go in and sort of have the really fun interactive part of the session.
So yeah, Murtaza, maybe just look that up. It's complicated, and I think I don't want to say things that are wrong. So yeah, and can you explain transmute? Yeah, no worries. So transmute is the intersection of select and mutate. So it'll delete it'll drop every column that isn't in here. So this will have postcode is postcode and price per room. So transmute will it's like mutate combined with select. So you can see like we're selecting postcode is postcode and we're selecting price room is price per room. So it's the same as doing like mutate price per room is equal to whatever, and then select postcode comma price per room. So yeah, it's kind of it's yeah.
All right, I might send us all in. Please go into the rooms and we will have someone go in to join you.